So in this expression, we have a rational expression, so I have a fraction with fractions inside of it. So what we have to do is combine the top into one fraction, not the addition of two fractions, and the bottom into one fraction. Then we can actually simplify. So if you watch my fraction video on the butterfly method, this is why I teach regular fraction numbers with the butterfly method. So remember the butterfly method from my earlier fraction video means that you multiply by the opposite denominator. And that is going to generate your common denominator. So multiplying the top and the bottom by the opposite denominator. And I'm going to do the same thing here. This is x over 1. So I'm going to multiply by 2x plus 1 over 2x plus 1. And I'm multiplying this by 1 over 1. So this looks really, really messy. But we don't want to FOIL anything out. We don't want to do anything other than get that common denominator. So now I have x plus 3 times x plus 1 over x plus 3, x minus 2. And now I have that common denominator. Again, I'm not going to simplify anything until I'm totally done. 90% of the mistakes that are made with rational expressions is because you start simplifying too early. And the step that I'm showing right here, you don't necessarily have to show this step if you understand how the multiplication is working. So now as you can see, we have common denominators. So again, the butterfly method is what generates these common denominators. Now that I have the common denominator, I'm going to have x plus 3 times x plus 1 plus x times x minus 2, all over that common denominator. So remember, when we add or subtract fractions, we don't add the denominators, we only add the numerator. So I have one fraction right here. It's not a pretty fraction, but it's one fraction. Then I'm going to have x times 2, and I'm just bringing that x to the front because that's the convention, minus 2, all over 2x plus 1. So here there are a couple of different ways that I can simplify this fraction. I can use my fraction rules and take this denominator and multiply by the reciprocal, because if you remember, fractions don't have a defined division symbol. It has to be done with multiplication. Or if you learn the sandwich method, which is kind of a more progressive view on this, you can utilize the sandwich method as well. So now I'm going to fully combine my two fractions. I'm going to have x plus 3 times x plus 1 plus x times x minus 2. And all of that is being multiplied by 2x plus 1. Then I'm going to take that denominator, which is going to be x plus 3, x minus 2, and I'm going to multiply that whole thing by x times 2x plus 1 minus 2. So this is not a very pretty answer. And then from here, we're going to have to take it further and see what we can do with simplification. And again, depending on if you're working in MyMathLab or other programs, that's going to dictate how far you're going to take this down. So I'm going to have 2x plus 1 distributed times x plus 3 times x plus 1, so I'm just distributing that term through, plus x times x minus 2 times 2x plus 1. So I just distributed that 2x plus 1 to every single term. What I'm going to do here is I'm going to distribute this x inside the parentheses to see if that gets me anywhere. It may or may not. I'm just trying to get a product here. So when I do that, I have x plus 3, x minus 2, and then I'm going to distribute that x through, and I'm going to have 2x squared plus x minus 2. Okay? So 2x squared plus x minus 2. From here, I'm looking for, is there any common term that I can cancel out? If not, this is about as simplified as it can get. Potentially, the lab may want you to do all the multiplication and all the foiling, but typically when we're simplifying something, this is simplest form. Now, this is an interesting problem, Holly, because typically things are going to cancel out, and we're not in a situation here where anything is really canceling out here, because I don't have it on both sides. So, interesting question, not the best looking answer right here for what you're doing as you simplify it down.